So welcome back to the second half of the fourth class of data analytics. So the first half, not only did I start with a bit of a review on what we did so far in the first three classes, started on the concept of visualization, right? And so far it's very, very dry. It's just basically I'm just asking you to show some plot, right? And so far, aside from some pretty looking mathematical object, I'm just asking you to show a visualization of some data, basically just points. Okay, so it's quite dry. Don't worry about it. We'll start to get more interactivity, and this is where the second half comes in. Now, before we get to interactivity, I want to ask, and I think I asked students during the break, what's the difference between interactivity and animation? Interaction and animation. Interaction is something that you and computer are playing off one another, right? So you interact with the computer program. So in this case, if the visualization is a computer program, you interact with that visualization. Animation is like you watching the show. Okay. But either way, if you think about it, fundamentally, both animation and visualization enables you to watch more than one picture. Does that make sense? Okay, so let me do this. Let me show you. Okay, we had this thing, right? We had this plot. Okay, let's say plot, right? And sine. Oops. Can I just start a new one? Plot sine of x, comma x from minus. Now, can you do this in your computer as well? Escape pi, and you will see the suggestion. So make it pi, right? And then plus pi escape pi. Okay. Right. Now, obviously, so that's one picture. Okay. I'm going to show you another picture just right next to it. Yeah, let's okay, plot this, and right next to it, another picture. And now I'm going to say minus 2 pi to plus 2 pi, right? Minus 2 pi. So basically it's you go as far, twice as far to the left, twice as far to the right. But alternatively, I'll go to minus pi to plus pi, and I'll put 2 over here just to increase the frequency. In this case, the same thing, right? Okay, right? So the picture looks the same, except now they're both going from minus 3 to plus 3-ish, right? Okay, fine. So if I want to show you more than one picture, I have two options, okay? Well, three options. One, I just show two static picture, okay? Two static picture, okay? Two, I can animate. What do I mean by animate is I make this my picture, right? And then I save it as a GIF file, okay? In fact, I don't want to just have two, so let's do this. Let's be a little bit more clever and say table, okay? Okay, type along with me. And then copy here, table, right? And instead of 2 here, you put I blank, so that I times X, right? And then comma, I from 1 to 5. Okay, so how many pictures am I going to get? 5 pictures. 1, 2, 3, 4, 5. Okay. Now, again, I want you to see 5 pictures. If I want to show you this as an animation, this is what I would have to do. So maybe I'll do this. Okay, let's say, first of all, to save something, I have to have a location. So let me save this. Save as, yeah, whatever, class, doesn't matter. Okay. And then say my directory, set directory. Okay. Notebook directory. Okay. Actually, I did this already, but I just want you to type along. So basically, notebook directory, because I already saved, it knows where it is. I set that directory to this. So I set output to the same directory. I can do it some other directory, but anyway, so that's my directory called teaching material. Okay. Now, so I did that. So what I want to do is export. Right. Okay. Now notice, go to help file, export, say just whatever the name of the file and whatever you want to export. Fine. So let's say I'm going to export. I'm going to name this something called sine x 5 times .gif. Yeah. Comma. And then I put in this table. Okay. So I did this, right? Now, once I enter, it's just going to give you the file name. So I go to this directory. Where's my directory? Directory is my lecture directory, right? Lecture. Oops, sorry. Course. There, there's my GIF, right? Okay. So basically, I'm showing you all 5 pictures, but you have no control. You have no control, right? So this is how I create animation. By the way, you can use Mathematica to draw a cartoon if you like it. But, so cat jumping, whatever. Okay, so it's not that looks like a fun thing to do. And in fact, you can do this to illustrate different setting of your app. So you can have app that have 20 different setting, and you just run through the setting and save it as a GIF and then show it. Okay, that's one way. Okay, but this is animation. Again, you watching the frequency of the sine wave go up, but you have no control. You have no control. This is not that good. Okay, it's entertaining, but it's not that useful. What would be useful is something like this, but somebody can interact with that frequency. And that interactivity is from the function called manipulate. So just as I put this thing inside export and I create an animation, now I'm going to take this thing. Okay. Okay. Now, instead of I to 5 and make a table, I change this word to manipulate. Okay. And then see what happened. Okay. Now, okay, you have I that can change. So I can make it 10. Okay. Now, in fact, let's start from 1, 5. Okay. Basically, there's reason why I put 1 in here, but you start with 1. Okay. So you don't want to end up with 5. You want to start with 1. Okay. To 5. Where is that 1 to 5? Here it is. Right? Here it is. This is 1. Where's 5? There. In fact, this is even better than table. Why is this better than table just now? Because that's now it's 1 through 3, 4, 5. Now it's continuous. I can make 1.3, guys. 1.23. Right? So it's actually a continuous number because right now this manipulate allows you to change anything from 1 to 5 continuously. Now, if I want to go back to discrete, I can go back to say 1 to 5 instead of 2 or something like that. Okay. Then it becomes more discrete. Okay. But let's not do that. Let's make it continuous because it's actually more fun. Okay. So now, unlike animation where you just prepare all the series of things, you can say, hey, these are 20 settings for my app. You can play with them. Okay, you can play with them. Now, what else? What else? Well, just now, right? Just now we have this thing called, okay, we can do this as well. We can have sine IX. And you guys remember what we did before? Sine and cosine, right? You can make the A create. Let's make it create cosine JY. Okay. Now, I want you to look at this carefully. Okay. Again, in Mathematica, different line doesn't matter. So just add more clarity. So this manipulate, just like table, expect two things: the thing itself and the manipulation section. Now, at first, let's have this first. Let's have this. Okay. I want to manipulate what? Yeah. I'm going to pause, make sure everybody look at me and say, you have this on screen, right? Because everything is going to build from here. So plot, use two input. One is the function. One is the range of function. That function is a function of x and I. However, you put x over here to indicate that's the range of plot. But the I comes out and gets specified here, becomes an argument for manipulate. So yeah, maybe I should do this. See that? This function has I and x. That x gets specified here because it's part of plot. But the I gets specified here because it's part of manipulate. All right? So you have that. Copy the whole cell, paste down here. Now I'm going to make it more complicated. I'm going to say cosine j, comma j and y, right? So now I'm going to make it a 3D plot. So I better change the word plot to plot 3D, right? And now, do I have just a range of x? No, I have y as well. Y from minus pi and pi. Okay. And now, comma. So just like this becomes 3 things, and this also becomes 3 things. J. Okay. All right. So now I can increase frequency in x. I can increase frequency in y. See that? This is frequency in y. This is frequency in x. What's cool about interaction is it also has built-in animation. You want to see it? So instead of having to create that animation, it was, I save it as GIF, which is doable. Why don't I just do this? Play. Play. right there, animation built in, okay? So it's running all the configuration. This is an 8 crate, right? It's an 8 crate function, right? So this one here, if you want to look at contour plot, you can do contour plot as well. Now, here's a cool thing. Okay, let me stop, right? What if I've changed from plot to contour plot? Oops. Oops. Contour plot 3. Ah, this contour plot because yeah, it's actually contour plot 2D because it's a function of 2D. So this is a contour plot, right? This is an 8 crate. 8 crate. Now, this is how. So how many knobs do you have? In this one, I have 1 knob. Just turn the eye. Right? In this here, how many knobs do I have? 2 knobs. Okay. Hold on. Look at me. I'm going to add an option just to make it look nicer, comma, control, placement, put to the right. Yeah. So now the control is on the right. Yeah. So I don't have to keep, scrolling up and down. Okay. So I have this 1 control. I have this 2 control, right? Now, what's so cool about this? Well, not so cool, but this is this. You can use control to control other things as well. For example, I did contour plot and I did plot 3D, right? So those are my 2 options. So I'll make that option my choice as well. Okay. I call it I should plot, comma. Now the specification, because it's not a number, it's actually a set. It's actually a set. So I'm going to put in a set. So I should plot 2 things, either plot 3D or contour plot. Doesn't have to say 3D because contour plot already is a 3rd dimension of 2D, okay? And I substitute here. So now I can change the choice of plot back and forth, right? Okay. And let's put this, let's put this first. Let's list it first. So okay, it's on top. See? Okay. Now, one more example. I can also do this, comma, okay, control type. Now, this thing I happen to know off the top of my head because I use it all the time. Where would you find it? 2 options. Go to ChatGPT and ask, in Mathematica, how do you change or whatever, or go to Google or go to, or you just go to the page, manipulate and help page, okay? F1. But I remember now. So I say control type is pop-up menu. I use it so many times. Okay. So now it's a pop-up menu. A pop-up menu is nice if you have a long list. Otherwise, it makes it very cluttered. So this is just a fancy looking thing. Now, one more thing. What if I don't want it to start from 1 to 5? I want it to go to 1 to 5, but I want it to start at 3. I put initial value, okay, comma, 3. So now it starts at 3. Let's make this one start at 2. Okay, And I and J doesn't really make much sense. So I'm going to call it something like frequency in X direction. And I'm going to put something like frequency in Y direction. Okay. Right. So it's a lot fancier, right? It's a lot fancier. Okay? But certainly it's not. So this is the simplest. So this is very embellished. Now I can normally even the name of the function, I would have this as F. Okay. So I would say something like F plot P. Okay. And I would use something like, okay, it's a plot function. I want to, what would you prefer? Let's start with plot 3D. Okay, and say plot function. Okay, and so normally it would start from the left. So if I didn't have this, it would start with contour plot. But if I did, okay, so now it starts here. Right? So this is fancier. Okay, and you know, you can go do animation. There's no animation here because it's only two shorts. But here you can do the animation. Right? Okay. So that becomes your animation. Right? Okay. So this, tell you what, I might as well, I will give this to you so that because, you know, there's a lot of bracket and you might get lost in all the bracket. But certainly you don't have to, okay, well, yeah, your hand in should look a little bit like this. So you can do this, right? So you can choose contour plot or plot 3D. Let's stop. It's giving me a headache, maybe. Okay, it's giving you, okay. And now you can change. So this is what I mean by interactivity. Okay, this idea of interactivity is something I wanted so much when I was your age. You know why? Not because I studied physics and economics when I was your age. And in economics class, there's this thing called ISLM curve. Basically, and this is not mine, I download this from, I'll show you where I download it from. But this is not my work. This is called liquidity curve. Yeah, let's look at this guy. It's kind of weird why it's not coming up. Okay. Open. Oh, hold on. Let me save this before I forget. Open. Demonstration. It should say something about economic curve. Hold on. Cost input. No. Yeah, maybe this one. I'm not sure. Yeah. No, that's vitamin C. Hold on. Let me try. I think I have it somewhere here. Let's try. Find, open, and let's go to another class maybe. Something about liquidity curve, I think. Yeah, there's this ISIM curve model. There, that's what I want to show. Okay, well, anyway, doesn't matter. The point is that when I was an undergraduate first year in economics, I was doing this line with pen and pencil. Okay. And I thought, wouldn't it be nice if we have like a computer algorithm, a computer program that allows me to do this kind of thing? So I can say how the relationship between variable works. And now there it is. Okay. So, when I was your age, I didn't have this luxury. So it was very difficult for me to get an intuitive understanding of ISLM curve. It's one of the most fundamental curve in macroeconomics. Okay. This was basically due to John Maynard Keynes, and his work was crucial because the world was under the Great Depression in 1929, and his idea was how to push the aggregate demand by using government spending. Anyway, so and then this whole thing about macroeconomic, not Keynes, but somebody else, I think Marshall or something, and they all developed this whole thing around aggregate or macroeconomic demand supply curve, and that's what this is. This is macroeconomic demand supply curve, and it has so many slope parameter, right? So how do you adjust for the intuition that, okay, if this curve goes up, if this curve is steepened, what would happen, the sensitivity and all that? And that's just with linear line, right? Imagine with curvature, okay? So I wish I had this when I was your age. I literally imagined this in my head. Okay, and this is, of course, somebody else did it, Keynesian ISLM model. So this was done, maybe 10 years ago. Okay, but that's basically the power of interactive mathematics. This is also a good example. I don't mean to see. It's got so many parameters. Okay, this is what I want you guys to do. Okay, if you're in like health and well-being, if you're in like smart cities, you have domain technology that has knobs. Okay, think of it as these parameters are knobs. These are settings. These are configuration. These are things that can be adjusted, and it has different effects. When you move this, it does this. It moves that. It blah blah blah, and God knows what, right? So this has to do with vitamin C loss in food during heat processing and storage. So this is a perfect example for, let's say, a health and well-being solution. Something about this. And you can say, okay, because of this, I can adjust this parameter and blah, blah, blah. And because of this innovation, maybe you have one picture like this, and then you have a button like this and say, okay, this is competitor, this is my, or whatever. Okay. So that's what I want you to have as a tool, interactive visualization. And when I say interactive visualization in this sense, it's beyond data analytics. Okay. Remember, with data analytics, you visualize, you get insight. Or if you're a data scientist, you visualize, you understand your data, you build your model, you do analysis, you present your analysis to your client. That comes in the form of visualization. But when I say visualization in this sense, right, it could be something about how your product would look like. Okay, so that's why I want you to really pay attention to this manipulate function. It's very powerful. And in fact, it's one reason why I use it for teaching purpose. Okay, it's something that you wouldn't have. Technically speaking, if you are very good in programming, in Python, there are libraries that does this sort of thing. But it's not that easy. It's not like draw a picture, manipulate this. You have to write like 3 pages of dash or something. Ask your friend here, Kong Kan. Okay, so it takes forever. I mean, I gave them a relatively simple job last year. They still haven't done it because it takes a long time to debug and all that. Okay, so this is very simple way of interactively visualize. I'm just giving you an A grade just because it's easy to understand. Now let's go back to this. Okay. So if you go through the notebook, you see here, right? These are all options, right? Plot label sign, okay, image small, but basically you just need this and this. Okay, so there it is. K is the frequency. Okay. Then again, choice of function. Here, you rely on this object called country data, right? Now, happen to be, okay, you can type along if you like. Well, first of all, geolist plot. Okay, geolist plot. Okay, geolist plot is a function. So, function F1, geolist plot. Okay, there it is. It plots all kind of stuff, right? So this example, Southeast Asia, this is all kind of things. So obviously you can do little tricks like, you know, relief 3D maps or whatever. Okay. Now, plot style, I just add a color because I didn't like the yellow. Let's say I put in blue, so forget that. That's not important. But here's what it means. Manipulate here is a choice of country. And I happen to use this thing called entity value. Entity value is like a encapsulated database. Okay. Remember I told you that if you have Alice, you have information about her birthday, her education, her height, her weight, right? What those for entity value of certain types, Mathematica has sort of like a baseline data set. So this one has baseline country data. Now I'm going to look up country data called Thailand. So this is a bit like association, right? So I'm going to take country data named Thailand. This thing is an entity value. And the list that I can choose from is country data of the United Nations. So it's going to list all kind of country. So you can see that these are all the country in United Nations. Okay. So let's go to Sri Lanka. Okay. Right. Okay. Let's go back to Thailand. Tuvalu. Tuvalu is in the Pacific. All right. Okay, let's go back to Thailand. Okay. Right. Now, obviously, you can guess what comes next. There's so many options, right? Right. So this is working with what kind of data? Well, this is more like big data, right? You're not just dealing with number, right? You're dealing with literally geographical map, right? It has all kind of information. Maybe, you know, the country data, by the way, is like a whole thing about the country. So location, flag, population, number of COVID, maybe, I don't know. Okay. Now, I already show you this, but again, this is a more elaborate version, and this is in your textbook. I strongly encourage you to line by line type this in yourself. As you type in yourself line by line, it will make sense or may not make sense. What is it? Plot label. What does it do? And every time you are asking yourself, what is this? You just go F1, right? So this is in your, you know, textbook. So again, I want you to key in individually. I don't know what page that is, but yeah, it's in, you know, this section. So it's in your textbook, type in line by line, okay? And you can notice that all this, not only do I give you a function, I give you a lot of option, and the option is set as a control. So I have all kind of control stuff. So this thing has so many control. I can choose to plot this function, that function, that function, that function. I can increase this, I can decrease this. I can fill the top, I can fill the bottom, I can fill bottom, I can make the image big and small. I can use different theme. By the way, this is called theme, minimal, okay, maybe scientific or business. I don't know why business theme is big, okay? So this here are multiple control. Again, I put control placement to the right because I can put it on the top. Top, yeah. Let's make it. So, right. Now this is a bit of a fun example for those of you who've done calculus in high school. You know about Pascal triangle, right? There's your Pascal triangle, right? And you can make M as big as you like. Okay. So list point 3D. Okay, and this is the old faithful example we saw before. Okay. Okay, now you guys remember the viewpoint thing? Yeah, now yes, you can do this by hand, but this is what I mean by parametrically, right? So I can animate the viewpoint. I can animate this viewpoint. So it's not just changing the data, but I can change the viewpoint as well. But obviously, you know, it depends on which application. Okay. Entity list. Not, okay, well, this is a little bit, yeah, that's a fun example from mathematics, but you don't need to know that. These are fun things that mathematicians kind of do. Okay, so you don't need, this is not data analytics. It's just kind of like a additional. Now this is more elaborate. This is an example that I think I copied from the source is from Mathematica notebook, I think. But anyway, the idea is here. Let me show you. Okay, this is very advanced, but you see, the only thing you need to know is this. Okay, this is what I plot. Okay, this is what I plot. I plot entity value. Okay, and that entity value, instead of country, I plot all the United Nations, capital city. Okay, and I use this thing called projection. Projection is well, cartography. Okay, this is the one I'll show you what the projection looks like, so you see what I mean. Okay, so this is how the map. Basically, a map is a 3D, a 2D projection of a 3D a surface on a 3D. Okay, so yeah, there are many ways. Okay, but within this, not only that, I look at the capital city of everybody, and I use the computation called find the shortest tour. So this is where you can't rely on things like, you know, remember I told you that Tableau can do interactive visualization? Well, it can't solve the problem. So you have to solve the problem and then export it somehow in some kind of data format that is agreed upon by both you and Tableau. Whereas here, this is actually a very important algorithm. It's a built-in function. What it means is that it tries to find the shortest path possible. So if I say, this is all the city, I want to tour all the geolocation. So the geolocation is the position of all the country. So, sorry, let me say again. My geolocation is the position of the capital city of all the countries in United Nations. Yeah, that's my geolocation. I solve this thing called distance and tour. Tour is like, you know, where do I go next? And then I create this path from the tour. So this path is that blue line. Okay. So imagine now this data happens to be a built-in from Mathematica called entity value. In real life, you would work with data that you import from something else. So imagine that Mathematica doesn't have longitude and latitude of all the countries from United Nations. So this step here is not just a one line. You would actually have to import from Excel or something like that, right? And say for all the country in United Nations, what's the latitude, what's the longitude, and store that, and then look it up and then create a table. So it's a little bit more involved, but this is basically because it's simple because entity value happen to be built in. Okay, because it's quite a common knowledge, you know, where cities are. Okay, so this thing is your data, basically. This thing is your data. This thing is your computation, and this thing is your visualization, and this thing is your interactive visualization. So you can choose color, you can choose location, you can use where you're starting from. Okay, obviously, I start from the Thailand centric. Okay, but I can certainly start from Europe centric view. Okay, so if you use this thing, latitude 0, longitude 90, that would take you sort of like right here. Okay, which is very close to Thailand. So I didn't put Thailand at the center of this, but close to the center. So basically, I put the center here. Okay, so longitude of 90, 0 latitude. If I want to go a bit north, then I can certainly move the latitude up or down. Okay, so okay. So this is what I mean by interactive visualization. Okay. How are we doing on time? Okay. Now, I want to show you, but I don't want you to follow the step typing because it has too many lines, okay? You're not going to be able to do it in class. You can follow it with your textbook in your own time, but right now, don't bother typing this in. It's going to take forever, okay? Just like this thing has so many lines. Well, I wanted to show you this, okay? Now, I use this example because, well, it's kind of a convenient example of interactive design. I actually taught some lecture that has to do with the design of visualization of data. Okay, and that's sort of like what we're going to start with next class. So, for example, when would you use histogram? When would you use contour? Why would it make sense? Okay, so maybe I'll start with that next time. But right now, I just want to go to this section 2.2, which is to say to encapsulate interactive design. What I mean is that here I'm going to apply this manipulate tool, right, into a way of parameterizing your design. So if you think of it this way, let's say this is your logo, right? Imagine this is your logo. Logo is your trading company, right? And okay, I designed this logo, but maybe I can change a little bit. I can make this color red. I can make the globe flatten. I can use the relief map. Okay, I don't want relief map. Okay, so these are all interactive, right? Think of visualization. It can be interactive. Okay, now imagine that this is a design job. Okay, so you can literally use this to do design proposal. Okay, likewise, if this is not a design of a visualization, but let's say a design of some thingamajig you make up. Okay, how would that work? So that's why I'm going to give you this example. It's like a logo design exercise. But, a logo can be 3D. So you can actually design object and 3D print, whatever. It could be a coffee cup, coffee mug. It could be an app. It could be a bicycle. It could be an whatever. Okay. So think of your 3D project, 3D printing. Think of your kind of app design, all kind of stuff. You can do it. Now, what I want to show is encapsulating. What I mean encapsulating is I want to wrap the whole process. Instead of having just this, let's wrap the whole thing into basic design template or default design template. Okay, so don't worry about following nitty-gritty design. This is just an example. Okay, but I want you to understand the concept. So first thing first. Whenever you are going to do interactive design, just like before, I'm going to do interactive design of a sine wave, but I didn't start with interactive design. I started out with a static design. So start with a static design. So let's say I'm going to prototype initial design parameter. Okay. So this is okay. This is a specific example. So I'm just going to show you. I use a lot of module here because this thing that I'm going to be using locally. It has parameter like dot, color, horizontal, step. So these are all kind of like geometric specification. Okay. Now, I happen to draw a few things. I draw the letter I and I draw a letter E because, I'm creating a logo for industrial engineering or intelligence engine. Okay. So this is my doodle. This is my doodle. Okay. So imagine I doodle in pen and pencil, and then I turn this into a 3D object. Okay. Happen to require one cylinder, one sphere, a couple of slabs in colors. Okay. So now it's very static. It has a dimension. It also has a viewpoint, right? A viewpoint, which is fixed. So I play around with this until I'm happy. Okay. Now, imagine if you were to do this in an old-fashioned way. You would say, show this version to your client. Your client would say, I like this, but I want this thing a little bit longer. You come back, and next week you say, okay, a bit longer. Yeah, I like it, but you make it too long now. Let's make it, you know what I mean, right? So now imagine that you can interact with the client. Okay, you want yellow, fine. You want green, fine. You want long, fine. You want short, fine. So all this becomes parameter. And the parameter is a constant that is changeable. So as long as I'm drawing this picture, the width, the color, the height, these are all fixed. But it's a fixed number that can be changed. So now I encapsulate it. Well, I can go to manipulate right away. But now I want to do something more clever. Okay. Let's say this is my design. This is my design number one. Okay. I know my client is going to change it, but this is my starting initial design condition. So I'm going to save this under a whole bunch of, I put the word specific design one. So my specific design one would have all this fixed. Okay, color palettes, all this thing. I'm gonna shift enter. So now it's known. For this example, I make two designs. This design corresponds to this picture you saw. This design corresponds to another picture you haven't seen. Okay, so I'm gonna. It's like those setting thing where your client can mess with it, but then it gets so out of control. You want, oh, let's start from the beginning. Go back. If you haven't saved the initial configuration, then you kind of lost, right? So this is kind of like two configuration. So I save it. Okay. Now I have this function that I create for myself because I'm gonna use a lot. Okay. It's a function that draw that thing. Okay. Okay. So there. So now what happened is this function, okay, don't have to worry about the detail. This function, okay, takes in just one object. That one object happened to specify a whole thing. Remember, univariate function can take in a whole bunch of things. This is exactly what I mean. This is the convenience. Now, notice that I define this specific design one as a default. So when I call this thing here, local design with no specific design input, it reverts back to this picture. It's going to give me this picture because this picture is spec design one. Now I also make spec design two. Let's say that's alternative, right? And so imagine, and then you go to your client make another one, becomes client design three, save that, continue the conversation next week. Don't have to start from scratch, but you get the point, right? So there's one default and there's one design alternative. And this is it. See, they both have a long shape. So there's an I, there's an E, industrial engineer, okay? But same concept. You are not drawing two pictures. You're drawing one picture, but the picture is parameterized. Parameterized by color choice, parameterized by shape, parameterized by length, by width, and parameterized by viewpoint or perspective, right? So now I can make this some kind of like a design function, and now I do this. So now I go to my client. I start with my initial design. and I can do, you know, and this becomes something more fun. Okay. Well, I don't like this. Okay. See that? So let's say this is my client looks like this, right? And then, oh, it's such a mess. I want to go back to original design. Okay. Okay. Okay, mess it up again. And let's go back. Right. Okay. And I actually have, I think somewhere where I animate, but I didn't put it in the textbook because this is getting a little bit too far. But certainly I can do this. I can interpolate the parameter. I'm just going to describe by hand because I don't want to waste time. Okay. But I think I can show you the result of one such thing. So you can imagine that between this one and this one, right? It's the change of parameter, correct? Right? So technically, what can I do? I can do this, right? Let's say I can do this kind of, yeah. Right? Or alternatively, I can do what I show you in the beginning of the, after we came back from a break, which is table of picture, right? And I save it as a GIF, right? So if I'm not mistaken, allow me 2 minutes to look up because this is actually not part of the class, but I can show you, might as well. I think, just a second. Okay, but this one that says logo design or not? Yeah, mine is 3D picture, 3D print. My logo design picture. There, I think there's one that's GIF. This one's a GIF. Okay, see? So in this case, what I'm doing is I'm not changing the design parameter, but I'm changing the perspective. So it looks like a 2D, but it starts from 3D. I think there's one that I start from one design and I merge to another. I'm not quite sure of this one. Yeah, see? So I'm not changing perspective, but I'm starting from design one and I keep morphing into design two. Yeah, and this is done parametrically. So I can do all kind of stuff. Right. Okay. So, well, this is this was a fun example. I was going to try School of Integrated Innovation. I was doing it for fun. Okay. So back to our example. This is a logo design, but same principle apply, right? So if you're designing a coffee mug, then a coffee mug has color, has shape. If you design an app has user interface, has button, has this. If you are designing a visualization, this visualization has parameter that controls it, right? So the concept here is that with manipulate, you can interact. And if you want to quickly show animation, you just use the play button, easy, okay? It would take for you forever to do this in Matplotlib, okay? But this is very easy, right? So I can, in theory, okay, hold on. This might take not so long, a bit long, because it actually does have to take a picture of a relief map. So, okay, it may not be that quick, but okay. But if I don't have a relief, it tends to be quicker. Okay, but you get the point. You get the point. Okay. Now, the concept here, and this, okay, yeah, this is the one. This is probably going to move quicker because this one doesn't have to the relief map. Okay. Back to here. So now the interactive visualization, right? The interactive visualization is basically your thing. You can do whatever you like. Okay. Now, next week when we come back, I would sort of like quote unquote principle. You know, for example, you can visualize only 3 things on a line. If you have like 20 things on a line, nobody, you know, that sort of thing. But what I want you to do, okay, what I want you to do is, because this thing now is so powerful as a tools for demonstration, there is a thing called demonstration community. So just key in Mathematica demonstration. Okay. It's going to take you to this project called Wolfram Demonstration Project. Basically, it's a community of everybody from, you know, scientists, artists, biologists, chemists, whatever subject, finance. Now, I might as well show you mine. When I worked on this, I was working for the Bank of Thailand. We were doing the risk management, basically calculating. You guys know, well, you know, banking system, right? Bank of Thailand regulates banks. Bank of Thailand regulate banks. In other words, you don't borrow money from the Bank of Thailand, okay? But the Bank of Thailand is who produces the money you use in Thailand, okay? Not only that, they want to make sure that banks that operate in Thailand, commercial banks that operate in Thailand, don't, you know, fall apart that easily, right? So they have to have the risk management. Well, one of the central cornerstone of risk management is if the bank has risky asset, and when bank makes loan, it's automatically a risky asset. Bank makes risky asset by, you know, making loans. Bank has to have capital cushion to buffer for that risk, so that if anything happened to that loan portfolio, it doesn't eat into the deposit. Okay, so the Bank of Thailand care not about the banks, but care about the banks because the bank has normal people's money. People put their money in the deposit account, and if bank go bust, people lose their money. So Bank of Thailand technically does not care about banks, but cares about the people that put their deposit in banks. Okay, so the idea is to calculate the risk. Now, the risk to how much buffer you need generally is called capital adequacy formula. That formula is mathematical in nature, and it has a few parameters. How does that function work? Same here. How does a sine function work? Right? You increase k, that's the frequency. You increase the amplitude, you shift the phase. So, you know, in a sine function, okay, I'm not going to show you, but you know that, right? A sine function, you can play with the frequency. You can play with the phase, which means to shift it left to right. And then you can play with the amplitude, which is how big up and down. Okay, so you can play with that. So those are the 3 parameters of a sine function. So instead of using your hand, you use manipulate, sine function, and play with the 3 things. Likewise, this was back in 2006, 2007. Let's search for my name. I only did 1 because I didn't need to do something else. Oops. Let's do Google search. Mathematica demonstration Pumjai or Maso 2. Yeah, it's this one. I don't know why I didn't show. The internal searching. Oops, there was an error. Hey, finance. Did somebody erase my thing? Rating. This is weird. Sorry. Let me try again. Mathematica. Demon. I haven't gone back for a long time. Rating. Right. Okay. I don't know. Okay. It's here. It's here. Okay. Anyway, so I wrote this when was it? Long time ago, 10, 20 years, 10 years at least. But basically, this is it. These are the sort of like basic parameter. Now, banks are not, banks are not just allowed to use this thing that I calculate, that I produce. This is a formula, but the input, that's where individual banks have to provide. Okay. So every bank in Thailand uses, it gets to use this function. And this function is not just banks in Thailand, banks all over the world. This is agreed upon. This is international standard by the Basel Committee for Banking Supervision. That Basel Committee is located in Basel, Switzerland. That's why it's called Basel Committee. And this, all banks, all commercial banks in the world has to understand this function. And that function, is sort of like a level of capital. Now, individual bank will use the same function, but they'll be at different place. Maybe one bank is here, one bank is there, one bank is here, one bank is there, depending on the input. Okay, so this is a demonstration of how individual bank, their level of capital changes as they take on risk, as whatever. Okay, so these are just some of the demonstration, but this is not that interesting because, well, for banking problem, the capital regulatory formula has to be simplified because the same application has to apply to like banks that are differently sophisticated. So sophisticated bank and not so sophisticated bank have to be able to use a similar formula. Okay, so the formula is not that interesting. In fact, I haven't done this for any other purpose. But if you go to demonstration project itself, you will see a lot more complicated. That example that I showed you about ISLM curve, that came from here. So that you will have to go to something like economics or something. So here, okay, here, you will see that, okay, example, mathematics, computation, business, social, life science, engineering, technology, our world, program, again. Okay, your homework, okay, is to start thinking about your project, like what you want to do. Okay, let's say I want to do something. I studied Basai. I want to focus on smart cities, and I want to study like logistic planning. Okay, so you go in here and look at something that's close to where you are. Okay, and what's so nice about it is this: when you go to it. Okay, let's go to life science. I'm just going to go to random example. Let's say ecology or something. Okay, and let's say it's going to something funny. Solar incident. Yeah, solar incidents on Earth's surface. That looks like a good one. Maybe it's even applicable for solar cell, right? So okay. So when you go to this, okay, just like my page, but this is a lot more interesting. This is the name of the demonstration. Okay, this is the name of the guy who made it, and it was 2013, and show some screenshot, right? Screenshot. Now watch this. If you go to download, so these are all download page, right? You can open in cloud, you can copy to clipboard, you can go to source code. Now, most people, if they don't have Mathematica software, they can download what's called a player, meaning plays with this thing as an output. But you have more than that. You have a real license. So what you can do is you can go to here, download source notebook. Okay, download source notebook. So let's say download source notebook. So where do my download goes? So my download goes to my download. There it is. Okay, you will see that it's the name of the project. It's the name of the project. it says something like, I'm not quite sure this is, I haven't used this for a while, but I actually created something like this to model COVID spread rates, but I was basing my model on one epidemiology model, which was, came from demonstration. What happened? Where did it go? I thought I put it on download. Yeah, there it is. Okay, I guess maybe I'm opening too much. Okay, well, I'm sorry. But anyway, what you're going to do is this. When you have the file, that file will look a little bit like my thing here. Oh, there. What? How come I don't see it? Download? Oh, it's on this. No. It should be in download file. Anyway, okay. It's gonna just cancel that. It's gonna look a little bit like this, where yes, you have something on the bottom, which is the visualization, but you have definition on top. The cool thing about it is it's all open. You can copy, okay? You don't even have to thank the author. The author intend to share. This is a complete open community, okay? It's good. You should give credit. I do that when I build on top of this. I say this is from I recommend you should do this. Okay, you should do this. So if you're going to create, like, let's say, imagine your final project is about creating an optimal device that captures solar cell based on location. And the location is projected based on this function that calculates how much energy you're going to get if you add this latitude, this longitude. Okay, so you are going to use the code that some of this that the author wrote and share openly, and then you build on top of that. So your application may have something that looks a little bit like this, but maybe something more. So maybe your solar cell device has an optimal control panel, right? But this thing is about input. This is about solar input. But this has nothing to do with your configuration of your solar cell contraption, whatever, okay? So maybe there's more that you need to play with. So you start with something like this, but then you have more screen, more graph, more plot, more simulation, more calculation, okay? And that calculation can be based on an actual physics or actual engineering specification, right? Because let's say you're making an autonomous orchard watering robot, and that robot has to be solar powered. Well, you're going to have to optimize the robot route vis-a-vis the energy, and that energy has to be optimized vis-a-vis how much solar you can pack or whatever, right? So that becomes like your capstone project, but that could start literally from something like this, right? So every single one of you, okay, every single one of you, next class, you will pick, okay? And then you will come and walk through. Do you understand what I mean by walk through, right? For example, I show you this this thing that, what is it, my own, okay? Oops. All right. Oh, I know why it takes a while, because I put this on Animate, so it keeps updating, and sometimes it does go back to the internet to do that. Anyway, so I walk through very quickly that this part, what is it? This is just to get the location, right? And then I can go here and I say, hey, look, this is an entity value page, guys. It looks like this. Let's go to entity value. See, entity value allows you to access information that's encapsulated. Okay, and find shortest tour. This is a mathematical algorithm. Okay, let's go look. This is based on find shortest tour. Oops. Shift F1. Okay, find shortest tour. Okay, it's find the shortest path, the total distance, and there's an example, and you can expand on it, and blah blah blah. Right there it is. I think this is a sort of thing where I draw it from. Right. So this is draw the geo path. That path is from here. See. And then I superimpose of it online. Then I have this thing called geoprojection, which is an option that I use over here called geoprojection. And, Lambert conformal. I think this one is Lambert conformal, right? So walk through this. So what I mean by walk through this is you kind of reverse engineering, right? So far, when you saw when I started with plotting the static first, right? Plot the static. Now make it interactive. Add more interactivity. Add more control. Add more option. Add this. Add this. Add this. Well, in demonstration, they have done all the adding. So this is very fancy, very complicated thing that they've come up with. Now you kind of like go back. What's the main function, guys? The main function is calculate the solar incidence. What's the main function? Project the light onto the earth, right? So you can sort of like work from something complicated back in. Okay. Why is that a good exercise? That's how you build complexity. Sometimes people don't teach you how to start from zero. They start from this. And you reverse engineering back, and then you improve. Okay. And this is a very good exercise. Okay. So I want, again, as much as I can, I want this class to be based on individual project. So you should think of your own individual project, intersect with what you can find here. And trust me, you cannot come back and say, oh, I can't find anything that's close to what I want to do. Okay, there are like 3,000 projects, or I don't know, hundreds of projects in here. Okay, so I want to do solar cell. I want to do artificial meat. I want to do a COVID warning. I want to, whatever. Okay, you'll find it. Okay, now you may come up with one or two or three if you like, but minimum one, and walk them through. Okay. And while you're walking through, you will also discuss what you would like to do with it so that we can help formulate idea of the project. Okay. So next, we'll spend time with that, and we'll spend time with the design of data visualization. So that will be your home. So today your homework will be to turn in just as usual, right? For your class in participation. But go home. Go to this, search Mathematica demonstration. Just have a browse. Maybe even before you have an idea, you want to do something in biology, but maybe you can browse in music. Just have fun. Have fun, okay? And then start to narrow down on things you want to say, hey, this looks like good set of tools. And then download it, go through the code. What's even better than this is that the explanation there's always an explanation. Okay, what's this variable for? What's that variable for? And sometimes it's technical, so they would actually give you a technical paper from which it's based. Okay, so for example, with my Basel, I can say, well, this is based on Basel Banking Committee, so this is not something I'm just making up, right? And people do that, and this is what scientific discovery. Sometimes you do that as well. So that's what a very good lab would do. That's what a very strong project pitching would do. Okay. And imagine how cool this is, guys. I mean, you've been trained to do all this pitching and all this fancy stuff just based on PowerPoint, just picture, right? You're not going to do that anymore, right? You're going to have an interactive analytics. You can have interactive configuration tools, right? That's going to make your capstone a lot more interesting than PowerPoint deck. right? And that's what I want you to do, guys. Because PowerPoint is really so high school. Okay, so pick one more better, unrelated, fine, but definitely at least one that's related to what you want to do as a class project. I'll figure out this sort of like how we do this, like, maybe we create a Zoom, everybody Zoom in so that it's easier to, talk from there. Okay. Dibutu, let's help with that. Okay. So make sure you do that. For those of you, again, the textbook, everybody's got that. So that's fine. Okay. Yeah. Again, I cannot emphasize enough the intention of me having you read this. You don't have to type, but you have to type the mathematical command because that's the only way you learn. Okay, that's the only way you learn. Okay, good. So with that, I think, yeah, we're just about dead on time. Okay, so I'll see you next week. Okay, I would like, if possible, for you to actually send the link. Say I chose this page, send that link to Dimutu so that everybody before class has that. So, okay, so have that at least by Friday afternoon, Friday evening. Yeah, make sure everybody's got one. One thing is I don't want you guys to have the same one. So, by Friday, if you pick on the same one, then we can say, oh, one of you guys has to pick something else. Okay, so by Friday afternoon, Friday 5 o'clock, let's say, send to Dimutu, and Dimutu check that it's decent and it's not the same one. Nobody, work on the same project. Okay, Cap. So I see you next week.